In ancient mythology, lightning was thought to be a weapon of the gods. Through time, people turned to superstition to control it. Church bells were rung to chase away evil spirits that caused the fire in the heavens.
Lightning has been likened in centuries ago to an electric fire that used to pour out of the clouds, and actually until Benjamin Franklin demonstrated that lightning was in fact the same thing, or made of the same kinds of things that make up static charges that we pick up walking across a rug. People actually thought it was fire.
Benjamin Franklin flew history's most famous kite into a Pennsylvania thunderstorm in 1752. He hoped to attract the mysterious force of lightning, and he did. Although lightning didn't strike the kite, minor charges in the clouds did travel down the damp kite string to a key, and sparks jumped to Franklin's knuckles, proving his theory that lightning is not fire, but electricity. A typical ground strike begins when negative charge from the cloud zigzags toward Earth, forming an electrical pathway between the cloud and the ground and inducing a positive charge along the ground. When the channel reaches positive ground, electrons rush out, creating the familiar flash of lightning and the shock wave of thunder. It happens too quickly for our eyes to see, but if you could slow things down, you would notice that as the electrons rush out, they leave positive charge behind that attracts more negative charge higher up the pathway. So the flash actually travels up, not down.
As we just saw, lightning is actually nature's simplest electrical circuit. The electric energy between the clouds and the earth builds up until the electric charge flows through the conducting atmosphere. A simple electrical circuit, like a flashlight, does the same thing. It has a battery, which is the potential energy, that is connected through wires to a lamp, such that when you close the switch or turn the flashlight on, current will flow from the plus terminal of the battery through the lamp back to the negative terminal of the battery. The battery's potential energy is measured in volts. The charge that's moving through the wires is called current and is measured in amps. The lamp, which is the load, is resistance to that flow of current, and it's measured in ohms and usually has the symbol omega. When we draw a schematic diagram of a circuit, there are certain symbols that we use to represent the different elements of a circuit, as shown here. We have the battery that we show is shown here, and that physically is drawn as a set of plates. The resistors, or the load of the lamps shown here, those are resistors, and so they are shown as a zigzag wire. And then the wires that connect the battery to the lamps, and the lamps to each other, in this particular case, is shown as a straight line with minimal resistance. To analyze circuits, we use Ohm's law, which gives us a relationship between the voltage applied to the circuit and the current that will be in that circuit based on the amount of resistance of the load in the circuit. So a very simple equation, voltage equals the current times the resistance. Volts in voltage measured in volts, current measured in amps, and resistance measured in ohms. So here we have a simple circuit with a battery, V sub S, some voltage, that supplies current through a load represented by R. Now, if the voltage in this circuit is 10 volts and the resistance is 2 ohms, what would be the current? Well, we know from the equation of Ohm's law, we can solve that equation for current, so we know that current would equal the voltage divided by the resistance. So the current in this particular case, when the voltage is 10 volts and the resistance is 2 ohms, that would be then 10 volts divided by 2 ohms, which would mean we would have a current of 5 amps. If the resistance is increased to 4 ohms, what would happen? Well, using the same formula, current would equal then the same 10 volts divided by not 2 ohms this time, but 4 ohms. And how much current would we have? Well, we would have 2.5 amps. So in summary, then, electrical circuit always consists of 3 elements: the potential energy, the electrical source, which we've been using a battery, which is then connected through wires to a load, which is a resistor, like in our case, a lamp. To calculate then the relationship between the voltage and current resistance, we use Ohm's law, which is the voltage equals the current times resistance. Now, go to Blackboard for this week and do some of the problems that are associated with electricity and circuits part 1.